The last standard of quarter two. You're here. Congratulations. Guess I don't need that on. And it's just going to be an expansion on what the fourth standard was, which was an exponential function. So this right here is the table for an exponential function. We're going to look at this a little differently, or we're going to, I should say, apply it to a real life situation, which is money in the bank. And it's going to be a lesson on if you start putting money in the bank, earning interest, that it's going to grow exponentially. And the younger you do that, like right now, the better. So let's go back to the basics. How do we know this is exponential? Because we look for the rate of change. How are we getting from one number to the next? We're multiplying by 2. Since we're multiplying and not adding, it's exponential. That means our curve is going to be a curve, not a straight line. We're multiplying, we're not adding. All right, did we have a head start here? Yes, our head start was 5. When we worked 0 hours, we already had $5. Or when we had our money in the bank accruing interest for 0 days, we already had $5. That means we're starting off with $5 in the bank. We've accrued interest for 0 days. All right, so how do we set up this equation? Y, our total amount of money, is going to be equal to the rate of change times x. Remember, x is an exponent. It's always rate of change x. We've been used to y equals mx plus b. That's for a straight line, but m is the rate of change. It's still rate of change x, but x is an exponent. And what was our head start? 5, but we don't add 5. We multiply by 5. Because it's exponential, so we're multiplying. All right, that's all review. That's what the last test was like. You had to build an equation from a table, and we're going to essentially do the exact same thing now, but we're going to give names to these placeholders. So that x, instead of just calling it x, like how many times are we multiplying? Is it 2 to the first power, 2 to the second power, 2 to the third power? Now we're going to be dealing with money in the bank making interest. And we're just going to assume that it makes interest annually, which is every year. So x is going to be years. It's going to be time. Remember, when we graph stuff, the x-axis is always time. The y-axis is money or distance. Those are your two most common types of graphs. The x is always time. So instead of just calling it x, we know it's going to be time. We're going to call it t, for time. That's a little bit easier. So this x now is no longer an x, it's a t. So nothing's really changed. We just turned our x into t so that we know that that means time. T stands for time. How many years have we accrued interest? So basically we're doubling our money every year. We started off with $5. After 1 year we had 10. After 2 years we had 20. After 3 years we had 40. That's a really good bank. If you could find one like that, let me know. So you're doubling your money every year, and that's what that 2 is. That's your rate of change. You're doubling. You're multiplying by 2 every time. You're not. Yeah. And then 5, that was our starting point. Well, you know how we had the equation y equals mx plus b for a straight line? Now we have the equation y equals c r to the t. Whoa. That's why I don't start off with all these letters. It's like, what do all these letters mean? But now you're going to have a pretty good idea what they mean. They just mean this right here. So C, I've been calling it the starting point, the head start, and it's actually called the initial point. Which initial and starting, that's basically the same thing. So initial point or initial amount. How much do you initially put in the bank? How much do you initially have? In this example, we had 5. So our initial point was 5. What was our growth rate? It was 2. We're doubling it. So that's where the 2 goes, is for the R. So R stands for rate of growth, which makes sense because we've always known it as rate of change. It still has the word rate in it. That's why we're using an R. So that's pretty nice that they use an R for rate of change. Just call it rate of growth. And T is your time, and that's going to be your exponent. That's what x is now. All right, so it's not too bad. Now there is one little wrinkle here, one little wrinkle in this equation, and that's basically if I wanted to know exactly how much money did I have after 1 year of this. Well, I started off with 5, and after a year, that 5 turned into 10. It doubled. Well, maybe that's not a good way to explain it. Let me just tell you for now, for today, and I'll explain it because this is a complicated part. I'll explain it better as the week goes along. But for now, I'm just going to tell you this equation has one little change to it. It's actually 1 plus r, not just r. All right, so it's c times 1 plus r to the t power. Now, why is that 1 there? That's the confusing part to this equation. Why is that 1 there? Let me try and explain it like this. Say we have $10. What is 50% of $10? It's $5, right? 50% of 10 is 5. Everybody knows half of 10 is 5. So if I said, give me your $10, just trust me, give me your $10, you probably wouldn't, but you're smart. But let's say you do, you trust me, you give me your $10, I say, I'm going to invest this money for you, and in a year, I'm going to give you another 50% back. So that's $5. 50% of 10 is 5. But if I only gave you $5 back, that means you lost 50%. You gave me 10, I only give you 5 back. You're like, what's up, dude? I thought you were going to make me money. You lost me $5. So I actually need to give you $15 back, right? I have to give you that 10 you gave me, plus you wanted to make money. I got to give you another 50% to hold up my end of the bargain. So the rate of change might be 50%, but it's actually 1 plus 50. What is the 1 stands for 100%. Let's say here's $10. What's 100% of 10? 100% of 10 is 10. 100% of anything is just itself. 50% of 10 is 5. So I have to give you back that 100% because that's what you gave me originally. Plus I have to give you the 5% that you earned. That's where the 1 comes from. All right, that the 1 represents the 100. That's just getting you back to the start plus the rate of growth, which was 50%. All right, and why am I using a 1 instead of 100? Because these percentages are all going to be turned into decimals. So 50% is actually 0.5. You move the decimal twice. Remember when you turn a percentage into a decimal? So 100% is 1. So it would actually be 1 plus 0.5 raised to the t. So after 1 year, you'd be at $15. After 2 years, it'd be another $5. It'd be another half of 15. So that's where this really starts getting crazier. After 1 year, you had $15. After 2 years, you're going to have $22.50. You're not going to have 20. You're going to be getting half of what you had at the end of the year. So after 0 years, you had $10. After 1 year, you had 15 because you added on half, 50% of 10. Now you're going to get 50% of 15. Half of 15 is 7.5. So you're going to add the 7.5 onto the 15. That's how you get to the 22.5. So you can see after 2 years, you more than doubled your money, but you're only making a 50% interest rate. It's called compounding interest. It grows exponentially, so it goes up real fast. You're not just doubling your money every year. So it's a little bit harder to find the equation from a table in a problem like this. You're going to have to find the equation from a story, and that's why this part is important, because in the story problem, in the word problem, they're going to tell you what the initial point was. What was the amount of money that you initially put in the bank? Like, hey, I got $100 for Christmas. I want to invest this $100. I'm putting the $100 in the bank. Okay, that's your initial point. That's what 5 would be. After 0 years of accruing interest, you'd be at 100 because that's how much you put in the bank. Well, what's the bank going to offer you for an interest rate? Let's say something more realistic, 4%. So if the bank offers you 4%, then you'd be at, well, your interest rate would be 0.04 because 4% is 0.04 turned into a decimal. Your initial amount was that $100 you got for Christmas, and you want to know how much am I going to have after 5 years of doing this. So your time would be 5. If that's the story, you take your $100 for Christmas, you put it in a bank that makes 4%, and you keep it in there for 5 years, then your equation looks like this. My total amount of money after 5 years would be 100 times 1 plus 0.04, the 4%, to the fifth power. So in the do section, I say use your calculator. You're going to need your calculator. You can't do, you add this together first. Remember, do parentheses first. So this becomes 1.04. Y is equal to 100 times 1.04 raised to the fifth power. How many of you want to do 1.04 to the fifth power by hand? Nobody. So you use a calculator. 1.04 to the fifth power, and whatever you get, you multiply that by 100 because that was your initial amount. And that's how much money you'll have in the bank after 5 years. And that's what today's problems are like. Simple 3 numbers: starting point, interest rate, number of years. How much money do you have after that number of years? You use this equation, you'll get it right every time.